Okay, so let's talk about inverse trig, right? And specifically, we're going to use this to find angles. Okay. So, all right. So let's talk first. What are inverses? So what I want to do is, what's the inverse of each of these equations? So let's say I have 3 theta. So this is 3 times theta equals 60. Well, to get to the theta, the inverse of 3 times is divide by 3. All right. Well, what if I had theta squared? Well, the inverse of a square is a square root, so I would square root both sides. Right? So now the question becomes, what if I have sine of theta equals a half? Right? And we know that sine of 30 degrees is a half, so there's an angle here, obviously. But what would be the inverse of sine of theta? And it turns out the inverse is actually just, we write down the same sign, right, sin, and we put a -1 as this in a superscript, right? So as this little above the n. And so now just like the divide by 3 is the inverse of multiply by 3, and just like square root is the inverse of x squared, sine to the -1 is the inverse of sine. Okay, and that's the representation. Okay, so let's take some notes. So, inverse trig functions. The inverse trig functions, right, they're represented by the superscript of a -1. So, sine -1, this is the inverse, and it's going to be inverse, it's a function, so it'll be inverse of something. So sine with a -1 right here means inverse sine. Cosine of -1 means inverse cosine. And tan to the -1 means inverse tan. All right. Okay. And so to make a note, each inverse, since sine of theta is opposite over hypotenuse, well, inverse sine should be the angle, right? So if sine of theta is the ratio, inverse sine of the ratio should be an angle. So all these inverses produce angles. All right. Okay. So one thing to note, just like any inverse, so an inverse of itself will give you just the input of the function. All right. So if we went back, let's scroll back a little here, just like if I divided both sides by 3, I would get theta. And just like if I square root both sides, I will get theta. So it's the same thing. If I take the inverse of both sides, right? So if I inverse this, I will get theta. All right, same thing. If I inverse cosine, so inverse cosine of cosine, I will get theta. And inverse tan of tan, I will get theta. All right, so if you take the inverse of itself, they're going to negate each other, and you're going to be left with just that input. All right? Okay, so you want to stop this and do classwork problem 1. Okay, so let's do a little problem here. So I want to solve for theta. So I'm going to have a few of these. So let's say sine of theta equals a half. So now I know the ratio. So again, this is sine, so it's a right triangle. I know opposites 1, hypotenuse is 2. But I want to know what the angle is that would produce that right triangle. Right? Well, how do we do it? I want to get to this theta. And right now, there's a function in front. It's sine of theta. So what I need to do is apply the inverse to both sides. So I'll take inverse sine of sine and then inverse sine of 1/2. Okay, so now I know it's not really clear, but you have to make a note here. This is not sin to the -1 times, right? And this is not sine times theta. These are functions. So it's inverse sine of theta. And this is inverse sine of 1/2. None of this is multiplication. Okay. All right. Well, we know from the previous problems we worked on, inverse sine of sine is theta. So I'm going to be left with theta. And then this is just a nice calculator, right? So type in inverse sine of -1, or not inverse sine of -1, but inverse sine of 1/2, hit enter, and make sure your calculator's in degrees, and you will get theta equals 30 degrees. All right? Okay, so what if we had tan of theta equals 1? Well, we can inverse tan both sides. Again, this is inverse tan of theta equals inverse tan of 1. None of these are multiplication. They're inverse functions and functions. Well, inverse tan of tan is just the input. That's just theta. And then inverse tan of 1, again, go to your calculator if you want. That'll be 45 degrees. Right? And, right, these are our special triangles. So we should know, these angles already. So this comes from 45, 45, right? X divided by x, that would be 1. So that's why it's 45. All right, and then our last one, again, cosine of theta equals a half is, again, is our special triangle. So If sine was theta was a half and sine was 30, then this should be 60, right? So let's solve it. So let's inverse cosine both sides. So I'll take inverse cosine of cosine, and then equals inverse cosine of a half. Remember, none of this is multiplication. These are functions, so it's inverse cosine of cosine. So I'll be left with the input, which is theta. And then go in your calculator, inverse cosine of a half should be 60 degrees. All right? Okay, so that's how we can solve some pretty simple trig functions, right? Solve for theta. All right, so stop this and do classwork problem number 2. Okay, let's put this all together from other stuff we learned. So here I have a nice right triangle. I have theta and I have a side and a hypotenuse. So I want to determine theta. And then what I want to do is find this third side and use a different trig ratio to find theta and just do it as a check. See if I get the same theta. All right? Okay, and this is just practice of doing stuff. So let's find theta. Well, first I have to figure out the trig I need. Well, here's theta. I have adjacent and I have hypotenuse. So which trig function relates adjacent and hypotenuse? Cosine. So cosine of theta equals adjacent divided by hypotenuse. Well, now look at this. We have a wonderful trig equation. And I want access to this theta. Again, this is not multiplication. This is not cosine times theta. So to get rid of this, I need to do an inverse. So I'll do inverse cosine of theta and inverse cosine of 2/5. Well, inverse cosine of cosine is theta. And now inverse cosine of 2/5 is a calculator problem. So plug it into your calculator, make sure you're in degrees, and I'll get 66.42. So in order for this to be a length of 2 and this is a hypotenuse of 5, this angle has to be 66.42. Okay? All right, so we're done with the solving the angle part. And if I have this angle, right, subtract it from 90, I'll get this angle. So that's pretty easy. But it's not part of the problem. All right, so now let's actually find this third side. Well, we have two sides of a right triangle. We have this angle, so we could do other trig if we want. I'm going to do the Pythagorean theorem. So I'm going to do hypotenuse squared plus the sides squared, right? Or equals the sum of the sides squared. So 5 squared equals 2 squared plus a squared. And that's 5 is squared is 25, 2 squared is 4, so I subtracted it over, and that's 21. Take the square root, and a will be the square root of 21. Okay, and I'm using the symbols here, so I didn't put in an equation. So this should actually have gone all the way across, but it's just a shortcut symbol. All right, so I know that a is square root of 21. So now I can find theta again. Well, now I have a couple choices. I have opposite and hypotenuse, so I could do sine. I have opposite and adjacent, so I could do tan if I wanted to. So I'm going to do sine, though. So sine is opposite, so square root of 21, all divided by 5, hypotenuse. And now I have this wonderful trig equation. Let's inverse both sides. So I'll get inverse sine of sine, and we know that'll be theta. And then I'll get inverse sine of rad 21 divided by 5. And then this will be a calculator, and you'll see that I'll get theta equals 66.42. Okay, so I just kind of checked this to make sure it was correct. All right. Okay, that's actually the end of the video. So you want to stop and just complete the rest of the classwork 3 and 4.